Okay, let's set this up. So I'm going to close this, and you can see here that I have a NetLab connection, and here is the same scenario. There's our PC at 192.168.1.100, and here's our PC at 3.100, and we've got three routers here. We're going to be configuring CBAC, or context-based access control, CBAC, on R1 over here, and we'll have to create our two access lists, and we're going to inspect the traffic coming into the fast Ethernet 01 port, and then that's going to create dynamic permit entries on the outside interface, allowing that traffic to return. But everything else will be blocked because we're going to block everything with our static ACLs on the outside. These routers have EIGRP routing protocol working, so they're exchanging routing table information, or they're exchanging their links or their routes with each other, so that they have learned about the other networks that exist out there. So that's going to be important when we do our configuring. And so let's run some quick tests just to establish that we have connections across the network. So we'll open up PCA right here, and we'll ping PCC, and we'll also attempt to do something else as well. So what I'll do is I'll open up PCA, and here's PCA, and we'll just open up a command prompt here, and you can see from the command prompt, if I do an up arrow, I can ping 3.100. So I can ping across the network, right? Also, I'm running a TFTP program here that has a TFTP server, but it also has a TFTP client. And I've put in the host on the other end of the network, 3.100, port 69, and I've attached a local file, dans.txt, right here, and we're going to try to send it to the other TFTP server on the other end of the network. On the other end of the network is this computer right here, and it's running the same TFTP program, but the server here, and you can see here we're going to see if we can send it across. Well, we have no firewalls in place, right? We just have open communications. We haven't written our ACLs or our CBAC firewall yet, so this should work. So we'll hit put, and you can see that we get a statement that it worked. We'll click OK, and we'll go over here to the server. We'll do a show directory, and you can see there it is, dans.txt. It's in the programs files folder, and we can examine it using Explorer, right? And there it is, and we open it up, and sure enough it has the statement that I wrote in it. So the text file transferred across. So we have communication to the other side of the network, and so now all we need to do is configure our access lists, our context-based access control, our CBAC firewall, our stateful firewall, and then see what happens to our communications. Right now, before we configure it on R1, I've got R1 here ready to go, but we want to look at the commands. I want to talk about the commands that we're going to be putting in and explain the exact commands that we're going to be using. Now, the way this is going to work is we need an ACL, an access list, on the inside of the network for FA0/1. So we're going to have an ACL here, and we're going to need another ACL on the outside of the network. And both of these ACLs are going to need to be extended ACLs, and they're both going to be applied inbound, going into the router. Now, from inside the network, it's going to be going into the router, but it's actually trying to leave the inside network. So it's going to be going into the router from this direction, right? And then the return on the outside, it's also going to be applied going into the router, but this will be for traffic coming from the outside trying to enter this interior network, right? And so we have to write two access lists, and these are the statements that we're going to write, and I've got it listed here. And so the first access list for the one that's going to be the first access list that we're going to write for the local network here, right, leaving the local network and then entering the router on FA01. We're going to talk about that one first. And so what we're going to do is we're going to say access-list 100, which is the number range for an extended ACL. and extended ACL is 100 to 199, so we just use the number 100, and we're going to permit TCP traffic to leave the network. So it's going to TCP traffic from the source network 192.168.1 network, and then the wildcard bits 0.0.0.255, which is the inverse of a Class C subnet mask, which would be 255.255.255.0. So the inverse of that is the exact opposite, which would be 0.0.0.255. So this will be the source network, right, to any destination. So we're going to allow TCP traffic from the one network to anywhere. And then we're going to permit UDP traffic from the one network to any destination. And we're going to permit ICMP pings from our one network to any destination, right? And then at the end of that, we're going to do an explicit deny IP from any source to any destination. So we're allowing TCP traffic to leave the network, UDP traffic to leave the network, and ICMP traffic to leave the network, right? But we're denying IP from any source, everything else is denied. All right, then we apply this to interface FA0/1, and then the command is IP access-group 100, the number of the access list, inbound. So that will apply it on this interface coming into the router right here. Okay. Then the outside ACL, the outside access list, is also an extended access list, and we're going to use just the next number up, 101, right? So it's a different access list because it has a different number. And what we're going to do is, first thing we need to do is we need to permit the EIGRP routing protocol from any source to any destination. We need EIGRP, these routers, to be able to talk to each other and send hello packets to form neighbor relationships so that they can exchange information about the routes that they carry. So we're going to allow that. And then we're going to permit 3 different types of ICMP messages. So we're going to allow from any source to any destination echo replies. We want to be able to get echo replies for our pings. And we're going to allow unreachable messages if a network is unreachable. And we're going to allow, let's say, a time exceeded message. Now there's other ICMP messages that we could allow, but I've just chosen a few that we want to explicitly allow through the firewall on the outside into the network, right? But as you can see on the next line, we're going to deny IP from any source to any destination. So we're going to deny everything else. So what are we denying? We're denying everything that's TCP. We're denying everything that's UDP. We're denying all kinds of essentially IP addresses. And so all kinds of traffic is going to be denied, right? So people will not be able to get through our firewall on the outside. Web pages will not be able to return. Nothing's allowed through, right? But what we're going to do is we're going to dynamically and temporarily allow permits to get through because we're going to inspect the traffic down here, and I'll talk about that in a second. So anyway, this is the access list for the outside, and then we apply it to the serial interface at serial 0/0/0, IP access-group 101, access list 101, inbound, right? Now, if we were just to leave it like this, right, we would have a problem because we'd say, okay, we're allowing, let's say, somebody to request a web page on TCP port 80, right, out. So they can request the web page coming out. So here comes the web request, right? And here's the web server over here. And so this guy says, I want to request a web page, so that's allowed through. The firewall says, okay, yeah, we'll permit TCP to any destination. So the request will hit the web server over here, but on its way back, when it hits the firewall, it's going to hit this access list, and it's going to say, well, we're permitting EIGRP or EIGRP, we're permitting ICMP, and we're denying everything else. No, you can't get through, right? Well, with the way context-based access control works is we're going to inspect the traffic as it leaves, right? So as this traffic was to leave, and the traffic will be inspected, and the permit statement will be seen for TCP, and it will create a dynamic return entry. It'll basically create a dynamic access list 101 permit statement that will permit TCP from that specific web server to the specific network on port 80. And we won't see it happen. We don't write it because it's dynamically and then temporarily created. After the traffic is done and the web page is delivered, the dynamic permit statement is deleted. It's temporary, so it's deleted once it's been achieved. All right, now how do we do that? Well, all we have to do is create some inspection rules. So we'll say IP inspect and then name, and then we need to give it a name. So we'll say CBAC context-based access control -FW for firewall. So this is just a variable name, right? It's all capitals. It's just a variable, a name for our inspection rules. And we're going to inspect TCP traffic, which will cover port 80, right? And we're going to inspect UDP traffic, which should cover TFTP, right? Now, actually, there's going to be a mistake in here, and we'll have to fix it and troubleshoot it later. But for right now, we'll inspect TCP and UDP, and then we're going to apply it to the inside interface, IP inspect, the name of our inspection rule, and then inbound. So that will apply this inspection to the inside interface right here. And this is what will inspect and then create the dynamic return permit statements. So let's do it.